So when you subtract those, what do you get? Yeah, 0.1176.
So the answer always has to be positive?
Yeah, what does this answer represent? You can answer that two ways. It's an area,
Or probability.
probability, because those are the same when they have a visual probability distribution. It's the area and the probability, and neither one of those can be negative. Right? That'd be really weird to say, yeah, the back of my trunk is negative 30 cubic feet. Is it a black hole? The shit is that? Negative area. Well, that'd be negative volume. It's even worse. Okay, maybe.
And that's the same as in number 5, part D, where you do the select 33 students.
Yeah, 5D is the straight up normal kind of, the way I'm going to show it to you on the test. 6D and E you're not going to see on the test, the uniform stuff I told you I'm not going to put in, but I put it there just to show you, yeah, you could, whatever, no matter what the distribution is to begin with, if it's greater than 30, it becomes normal enough.
Which one? Number 5 or 6?
5D is the standard way of doing this kind of problem. 6D and E are not going to be on the test. Specifically, because they have uniform, I don't care about those formulas. I put it on the practice test to show you that no matter what the distribution starts as, if you take a sample greater than 30, it becomes normal enough. And then I can use z-scores, look up areas. How many guys, anybody found like videos on statistical ideas? Anybody? YouTube was down for like an hour yesterday, but it's almost always up. So you're a little crazy if you're not finding extra help. I mean, I could sit here and say back in my day when I took statistics, flipping internet didn't really exist quite fully yet. So what were we doing? Looking at other textbooks and stuff. I mean, but now you can go to YouTube and type in there, explain normal curve to me better than my teacher, and then you get videos upon videos. Right? It's insane. I don't know if you want to pass. I don't know. Statistics, the more you understand the idea, the better you'll do. Algebra is sort of more, there's ideas, but it's more just mechanical. Statistics is more conceptual, like I put on the syllabus first day. It's a very conceptual, heavy class. Well, yes, it is a heavy class. Bless you. Yes? What section? Chapter, I mean? 6? Number 50? 50. 15. Oh, okay. So, this is that weird notation the book uses. Let me make sure that you guys can interpret this correctly. If the book tells me that X follows this, where'd it go? What the shit does that mean? And if nobody can answer me this, so I'm a little worried about homework getting done because it's a problem. Good. It's normally distributed. If it was binomial, there'd be a B there.
With a mean of 2.
Good. Mean, standard deviation. Those are the two most important things. So the mean is 2, standard deviation is 6, and it's normal. And then they ask you, for this one, this is number 15.
Yeah.
What value of X has a z-score of 3? So I know Z. I want to know X. Don't we have a formula that's solved for X that involves everything I know? Yeah, I have X is... So then you plug in mean, z-score, standard deviation. If I told you every step I take is 6, every step I take is 6, let's say 6 inches, because I can't do 6 feet. 6 inches. And I take 3 steps. How far have I gone? 18 inches. Now let's say I start at the 2 mark. Where am I now then? If I took 18 above 2 is 20. That's what you're going to get here, of course. Because what does z-score tell you? The number of these away from this. The number of these away from this. Do you guys remember that there's a question on the test you know for sure right now? It's going to be on the test. It's going to be one of two ways. It's going to be, what does the z-score tell you? And don't say a word about flipping area. What tells you area? The chart. And you can't even use the chart all the time. What's a z-score tell you by itself? The number of standard deviations away from the mean to a data point. Or the number of standard deviations from a data point to a mean. Whatever, however you want to say that. Right? What would a z-score of 2.5 mean then? That data point is 2.5 standard deviations away from the mean or above the mean would be even better because it's positive. Either what does the z-score tell you in general, or what would a z-score of 2.5 or negative 1.8 tell you about a data point? They both are basically the same, just one of them is a little more specific. Instead of the number of standard deviations, you'd say it is 1.8 standard deviations below the mean or something. Why do I put that in every test? Because understanding that is stupid important because z-scores rule over half this course.
Can we do 66?
Okay. Blah, 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 blah. Oh, okay. So, this one tells you that the heights, is it the heights or weights? Where'd it go? Weights for all 80 centimeter girls. Don't you? All the 80 centimeter girls go over there. It's like, that's a little strange. They have a mean of 10.2 and a standard deviation of 0.8. They're normally distributed. Calculate the z-scores. Now the funny thing is they don't have to tell me they're normally distributed for this. I can calculate z-scores for anything. It's just I can't turn them into probabilities unless I know it's normal. But here I know it's, I forgot already. 10.2 kilograms. 0.8 kilograms. I remember I was a fat little dude, but I loved it when they told me that kilograms, that number made me feel better. It's a lower number. Sorry. I was a hefty little porky pig dude. I'm not serious, but I'm still working on things. So they just want me to calculate a z-score. So they tell me, what about for a girl who's 11 kilograms? Can somebody tell me right now, without doing any work, will it be a positive or a negative z-score?
Positive.
Why? It's above the mean. Kabam. Right? So how do I set that formula up for the z-score? Yeah, my data point minus the mean. The mean always comes here. Divided by 0.8. And of course that's going to be, you guys hopefully can see it's going to be 1. Right? 0.8 divided by 0.8. And then they want you to interpret that. Well, how do you interpret this? Exactly what we were just saying. That means that 11 kilogram girl is 1 standard deviation above the mean. Bam. So that's how you do each one of those. Calculate a z-score, interpret it. Calculate a z-score, interpret it.
Can you explain
4B. Oh, okay. And stay with me. Here's a completely unrelated but totally related situation. Ready? If I told you the probability of getting somebody with red hair is 0.21, and I pick 4,000 people, how many would have red hair? Would I expect to have red hair? How many would have red hair? How many would I expect?
21%.
Of?
Of 4,000.
So you would do 0.21 times 4,000. All right, right? Now, look at number 4. Part A says, what's probably x greater than 302, right? A1. And then part B says, if I have 2,000 students, how many would I expect to have a greater than 302? Well, part A1, you calculate the probability, and then you take that percentage of 2,000. So I like that problem because it's showing you what you can do. When you finish this problem, what can you do with it? Well, here's one thing you can do with it. You can estimate how many to expect to do that. So, I don't know if I told you, when I lived on the East Coast, I worked at this little 4-year Methodist college. I'm not really religious, but and I placed everybody into their first math course. That was my assignment. We had a total student population of 1,600. At gross amount, we have 20,000. So it was a little easier there. But what I would do is I would estimate how many students will place into certain courses so I can tell the department, the math department chair, how many courses to schedule. Does that make sense? So I could see them, their incoming, how they did, the highest math course they took, and what their SAT was, and what their GPA was. And I had a formula that would predict, well, how many do I predict? How many do I expect? Here's how many are coming in. How many do I expect to place into 110 or 120 or 160 or 180? And then I can tell them, you should schedule this many courses, right? And I want to brag a little bit. I had a pretty damn good formula, right? But I mean, it wasn't perfect. Thankfully, that's why I can't just say, don't even take the test. I know where you're going to go. It came out decent on average, Anyway, sorry. So that's a real life situation where you use this kind of thing. Where are you at? Who starts class? Who's not saying anything? I don't have anything to say. Whatever you guys want to talk about. It's not awkward. What time is it? Oh, we got plenty of time. If you guys are all ready, we don't have to sit here. If I were you, if there's anything on this practice test that doesn't make sense what to do with it, you want to ask about that. Yes? Oh, part 3, you mean like the probably x less than 100? So, yeah, so when you do the z-score, you get negative 5.26, if I did that correctly. Off the chart, right? The chart says 0.0001, so if you wrote that, that's fine. But remember, that's for 3.5 standard deviations down. I'm 5.26 standard deviations down. There's approximately 0% below that. Yeah. But if you put 0.0001, that's fine, because that's the chart says that. And I'm making you use the chart, so you're like, come on, Jim. So of course you can write that. Yeah, so the real answer is 0.00000007. I'd say that's approximately 0, right? If that's my chances of dying tomorrow, I feel pretty good. Right? Like, all right. Somebody else might be like, so you're saying there's a chance I'll die? You know, well, yeah.
For C, you look up the z-score for 0.05, and then you use that.
For which? Well, I'm sorry. What are we looking at?
Sorry, for 4C.
4C. Yeah. Top 5%. So if you draw that, what's it look like? Top 5%. So if you look at 0.05 in the z-score chart, you're not going to get the right z-score. Yes, because you need the area below. Now, of course, if you look at 0.05, you're going to get the positive. You're going to get the negative answer. You just take the negative off. That's a shortcut. Or you look at 0.95. Yeah. Because you know the answer should be a positive because you're way up there. Yeah.
For A, how did you get the 27.27?
I don't know. So z-score is 0.6, right?
Right.
So then you look up 0.6 in the z-score chart. I got 0.7257. You never know. Double check me on that. Yeah, 7257. Is that cool? No? What happened?
I don't know where you're looking.
So what z-score did you get?
I don't think so.
6.
Yeah.
0.60.
Oh, that score. I was looking for the sixth.
Oh, no, it's a z-score. That is a z-score, so we look on the outside.
And then you just do the ones.
You look on the inside if it's an area. But that is definitely a z-score. A lot of times there'll be a problem where you have to do this thing. And people will do that thing and they'll get like 0.12. And then they'll look that up on the z-score chart. But I'm like, is this a z-score?
No.
No, it's the
No.
new. So tell yourself, especially write it well enough so you can tell what the hell you. Tell yourself what you're doing at that moment. You haven't made a z-score yet. Don't look it up in the z-score chart. You rounded it too much too, because it's not a z-score. It's a standard deviation. So you're the one doing the work. You have to know what it is you're getting at that moment, so you don't use it the wrong way.
Could you explain C again? So we're looking for 25 on the outside or inside of the z-score?
So which one? Sorry.
4C.
4C. Okay. So yeah, 0.95. Is that a z-score or an area? It's an area, right? It's a percentage, right? It's not a z-score. It's up here. Z-scores would be down here. So I'm looking 0.95 up in the body because that's an area, not a z-score. I only go out here if it's a z-score I have. And 0.95 is not a z-score. It's an area of the picture. That's why you desperately put areas up here, z-scores down here. So it's a visual clue. Oh yeah, that's an area I'm going to look in the body.
No, that's the area, not the source.
And you should be getting 1.645. Hopefully that's what past Jeff got. Yes.